Today we're going to talk about friction. Friction is an electromagnetic force that opposes the motion of an object. There are basically four kinds of friction. The first we're going to look at is called static friction. The word static has the same root as the word stationary, so this would be friction that resists the start of motion. So the object is stationary to begin with. The second type is kinetic friction. We know that kinetic means movement. So this is the friction between a surface and a sliding object. The third type is rolling friction, and oddly enough, it's friction between a surface and a rolling object. And lastly, we will look at fluid friction, which is friction that resists the motion of an object moving through a fluid. So what's a fluid? Well, I'm glad you asked. A fluid is any substance that is free to flow, such as gases and liquids. Now that you've got all that, let's look at what factors affect static and kinetic friction. The first thing is weight. The heavier an object is, the larger the frictional force. Duh. The only other thing that affects static and kinetic friction is the texture of the surfaces. If the surfaces are smoother, then there's less frictional force. Now let's look at the factors that affect fluid friction. Well, weight is still a factor, and it still has the same effect. Heavier object, larger frictional force. The only other thing that affects fluid friction is the surface area. The larger the surface area, the greater the force of friction. This is why parachutes work. Parachutes provide more fluid friction, slowing the jumper down. So how can we reduce friction? We can reduce static or kinetic friction by smoothing the surfaces, or you could use a lubricant. A lubricant is a fluid that fills the gaps between the surfaces, thereby reducing the friction. One more term that you need to know is the word frictionless, which just means there's no friction. Now that you know all that, let's work some problems with friction in them. Write down all of this information. And the first question says, what is the net force acting on the box? I recommend that you always start by drawing a diagram. The box has a mass of 350 kilograms, and we're going to push it with a force of 740 newtons. The force of sliding friction is 220 newtons, and that is always opposite the direction of motion. So to find the net force, we add up all the forces acting on it. We have 740 to the right and 220 to the left, so we would subtract those and we get a net force of 520 newtons. Now I want to know what is the acceleration of the box. The acceleration the box moves with would be the net acceleration, so we're going to use the net force to find this. Write down your given information. You just found that the net force is 520 newtons. You know the mass is 350 kilograms. Find A. And of course, F is always equal to ma. So write down your equation, plug in the values that you know, and put it in the calculator. If you've done all that correctly, you should find the acceleration to be 1.5 meters per second squared. Let's do another example. Write all of this down. The first question is asking what is the net force on the refrigerator. If the refrigerator is moving with an acceleration of 0.76 meters per second squared, then that is the net acceleration. So I can use that value to find net force. Write down your given information. And yet again, F is equal to ma. So write down your equation and plug in the values that you know and type it in the calculator. If you've done all of that correctly, you should get a net force of 340 newtons. But wait, there's more. Now I want to know what is the force of friction acting on the refrigerator. Well, let's draw a picture. The refrigerator is being pushed with a force of 920 newtons, and we know that the force of friction is in the opposite direction. The net force is always the sum of the forces acting on the object. So in this example, the net force is equal to the applied force plus the force of friction. We calculated the net force on the first question to be 340 newtons. We are applying a force of 920 newtons, so find FF. Hopefully, you get negative 580 newtons for the force of friction. Okay, one more example. Write all this down. The first instruction is to draw a diagram. Here we go. Here's a table, and I'm going to draw a pulley. Now I'm going to draw my two masses. They are each 1 kilogram. Whew, that's tough. Now I want to know, what is the tension in the string? Well, what is causing the tension in the string? Gravity pulling on the 1 kilogram mass that is not on the table is what's causing that tension. So we will use the mass of 1 kilogram and the acceleration due to gravity of 9.8 meters per second squared to find the tension force in that string. F is equal to ma, again. Plug in your values, type it in the calculator, and your tension force should be 9.8 newtons. Now I want to know the acceleration of the system as a whole, and we're going to assume that the table is frictionless because if it weren't, that would make this way too hard. We know that the tension force is 9.8 newtons. If I'm looking at the system as a whole, that means it's the two masses together, so the mass would actually be 2 kilograms. And I'm looking for A. Now this next part is radical, I know, but F is equal to ma. Plug in your numbers, type this in the calculator, and you will find that the acceleration is 4.9 meters per second squared.